Today we begin looking at sequences and series. These are things that occur in many different aspects of life, and it's important for you to understand the basics of these sequences and series. In particular, this is a place where we're going to transition from our use of algebra into beginning to create avenues that we can use in other areas, such as calculus, probability, things like that. Many natural phenomenon in our world exist as a series of numbers, a list of numbers. For example, a population. You can list the number of people each year and perhaps find a pattern within there. That list of numbers is called a sequence. So for example, 1, 4, 9, 16, 25 is a sequence. The definition of a sequence, if we just use the term sequence, we assume that it's infinite, meaning it goes on forever. And the domain or the input values are the set of natural numbers, 1 to infinity. And instead of giving the function a name and then defining the values as f of 1, f of 2, we normally just list subscripts and refer to the terms of the sequence. So in our previous example of 1, 4, 9, 16, 25, our first value would be a sub 1, our second value a sub 2, a sub 3, a sub 4, a sub 5, and so on. A finite sequence just means the same thing, except we stop at a certain value k. So there may only be 10 terms in the sequence, not an infinite number. One of the aspects of the sequence notation that you do need to note is that we define, instead of some f of x, we typically define a sequence based on some formula, a sub n, and then how we would calculate that. It doesn't always have to be a, so if we're looking at two sequences at the same time, we may have a sub n, b sub n, we could have c sub n. So let's look at how to find those terms of a sequence. Consider here the first 5 terms of each of these. So beginning with a, I'm going to come over here to the side. A sub n we know is 5n minus 2. To find a sub 1, we're going to do 5 times 1, and I'm going to draw that less like a subscript for you here, minus 2, which gives us 3. A sub 2, we're going to do 5 times 2 minus 2, which gives us 1. Which gives us 8. A sub 3, we're going to do 5 times 3 minus 2, which gives us 13. And if you continue that calculation, you get a sub 4 is 18. And a sub 5 is 23. Our second sequence here, b sub n, is -1 plus to the n power plus 1 over 2. So if we want to calculate b sub n, again, it's -1 to the n plus 1 over 2. To calculate that first term, we're going to have -1 to the first plus 1 over 2, which ends up to be 0. B sub 2, we have -1 squared plus 1 over 2, which is 1. B sub 3, notice we go back to, when we cube the -1, we get back to 0. And if you continue that pattern, you're going to find that b sub 4 is 1 and b sub 5 is 0. This just shows you that terms can occur more than one time in a sequence. And last but not least, I'll do c sub n right here. C sub n, when I plug in 1 for n, I get 1 over 1 plus 1, which gives me 1/2. C sub 2, I get 2 over 2 plus 1, which gives me 2/3. C sub 3, I get 3 over 4. C sub 4, I get 4 over 5. And C sub 5, I get 5 over 6. These formulas that we're looking at here in example 1 are what we refer to as explicit formulas. They tell you exactly what the term is for a given n value. I can ask you for C sub 100 in this, and you can find it immediately. Sometimes we are not able to determine those values quite so easily, and so we use what's called a recursive formula, and that recursive formula depends on terms that occurred previously in the sequence. So let's look at an example here. If we want to determine the first 5 terms of a sequence, we have been given one value here of the sequence, and we've been told that any a sub n in the sequence depends on the term before it. So for example, a sub 5 is going to depend on a sub 4, and then we'll add 5. So for example here, if we know a sub 1 is 3, then a sub 2 is going to be a sub 1 plus 5, which is going to give us 3 plus 5, which is 8. A sub 3 is going to be 8 plus 5, which is 13. A sub 4 will be 13 plus 5, which is 18. And a sub 5 is going to be 18 plus 5, which is 23. The first 5 terms, therefore, are 3, 8, 13, 18, and 23. Notice these are the same terms that we had in example 1, which just shows us that there can be different ways to define the same sequence. If you do the recursive formula for part B here, I'm going to list those terms for you and let you try them. The first 5 terms are going to be 2, 7, 22, 67, and 202.